Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today in this session I am going to discuss about different security problems in TCP protocol. So different types of security problems in TCP protocol. So in the previous session we discussed about different types of TCP attacks, different types of TCP tools that we are using for scanning and reconnaissance purpose in the network. So today in this session, the security problems in the TCP/IP protocol suite we are going to discuss. So generally security problems, so when we are applying security for the protocols or for the network, we are facing some problems in the middle of a network. We are facing some problems in the middle of network. So what are the problems we are going to face in the TCP/IP protocol suite? So generally the TCP/IP protocol suite, it consists of all the different types of protocols that are implemented in TCP protocol suite. So which contains all the different types of protocols, for different layers. So this all the protocols that were implemented in TCP/IP protocol suite. So before understanding the security problems in TCP/IP, we are going to understand the network architecture of OSI model as well as TCP/IP model. So we already know that OSI model consists of 7 layers as shown in the figure. That is application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So these are all the layers. We call it as 7-layer architecture or ISO reference model or OSI reference model. So the OSI stands for Open Systems Interconnection. So all the layers, each and every layers are presented to transmit the data over the protocols from the lower layer to higher layers. So how the data is going to be transmitted, and in the middle of the transmission of the data, what are the different types of protocols that were present to transfer the data. So these are all the different layers of OSI reference model. Compare with that, the TCP/IP reference model also having the 4 layers. The first one is, it is a network access layer, and the second one is internet layer, third one is transmission layer, and this is the application layer. So here we have to compare the both of OSI reference model as well as the TCP/IP model. So each and every layer having a different protocols in the OSI reference model, as well as we are having a different protocols in the TCP/IP reference model. So combining this, all the protocols that are implemented to transfer the data from lower level to higher level, the protocol consists of all these protocols. That protocol is called as TCP/IP protocol suite. So TCP/IP protocol suite that contains all the different types of protocols that are existed in different layers. So application layer contains some protocols, transport layer contains some protocols, internet layer contains some protocols, and the network access layer contains some protocols. So all these layers having some different types of protocols. So at the time of transfer the data, the protocols will take the place to transmit the data. But during that time, there may be some security problems will occur. So what are the problems that were identified in the network, over the network, we are going to explain in this session. So about this diagram, all the layers we have to understand from the OSI layer as well as the TCP/IP layer. So here The TCP/IP protocol layer consists of the application layer protocols, telnet protocol, file transfer protocol, SMTP protocol, simple mail transfer protocol, and DNS, domain name server protocol. And the TCP, UDP are the protocols that were existed in the transport layer. And the internet protocol, ICMP or IGMP, that were existed in the internet protocol layer. And the Ethernet, IEEE 802.1, 802.11. So some of the protocols that were existed in the network access layer. So because of all these layers were presented in the protocol suite, the protocols are able to transfer the data from lower level to higher level. The protocols are able to transfer the lower level to higher level. So now we are going to see the problems that were existed in the TCP/IP protocol suite. So here the TCP provides a fundamental communication service and used by many application protocols. So such as the HTTP protocol, FTP protocol, simple mail transfer protocol, some of the application protocols. So it provides the communication service from lower level to higher level protocols. So here, while transferring the data, while communicating the service to all the layers, TCP have several security problems. See, TCP have several security problems. So what are the problems actually? So TCP cannot guard a segment against the message modification attacks. So TCP cannot give the guarantee of the segments against the message modification attacks. So in the middle of the transmission, there may be a chance to modify that message. So for that message modification attacks, TCP cannot give the guarantee of that segments, that are against the message modification attacks. And this is the first one, the problem which were existed in the TCP security problems. And the second one, TCP cannot keep segment data secure against the message eavesdropping attacks. So whenever the message modification occurs with the help of attacks, automatically the message eavesdropping attacks will be there. So at that moment, the message will be dropped to the modifications. So that cannot give the guarantee, or that cannot keep the segment to be secure. And also TCP cannot protect connections against an unauthorized access attacks. So TCP cannot protect the network connections against the unauthorized access attacks. So somebody is able to hack the internet access, and they can able to build a connection, user-owned connection, and they can able to transfer the data to the destination. So at the time, TCP cannot protect the connections, network connections, against these unauthorized access attacks. So this is the main problems that were existed in the TCP. So one is what? TCP cannot give, the first one is what? TCP cannot give the guarantee on segment. For what? For message modification attack. And the second one is TCP cannot provide segment to be secure against message modification or message eavesdropping attacks. And third one, TCP cannot protect the connections against unauthorized access attacks. So TCP cannot protect the connections against unauthorized access attacks. So based on these main security problems, a TCP protocol having different issues with the different protocols. So that's in that, the first one is what? TCP sequence number prediction. So there is one problem. So attacker can able to predict the sequence number of the TCP, which they are going to access the next number. So in generally, the communication is provided in between the client and the server is like the format. The first one is what? The client is able to send the synchronous request to the server. Now the server is going to give an acknowledgement for the synchronous request. So for that synchronous acknowledgement, the client is going to give the acknowledgement. Client is going to give the acknowledgement. After receiving the acknowledgement to the server side, the server can able to provide the communication between the client and the server so that they can able to transfer the data. This is actual communication process will happen in the real time. So the client and the server can able to communicate by three-way handshake signals. So here you can say that the client makes a request to the server with the help of synchronous request, and then next for the request the server is going to give an acknowledgement for the synchronous request. So now server is going to give the acknowledgement for the synchronous request. Similarly, the client, after receiving the acknowledgement for the request, the client is going to give an acknowledgement for the response. Now server is able to provide a communication between the client and the server to transfer the data. So this is the actual process, the actual communication process that will happen in the real time. So now what will do with the help of attacker? So how the TCP is having the security issue over the transmission of the data here. So the attacker X here and the trusted client T is here and the server is here. So actually the attacker is going to take the handover of the client system, and here the attacker is going to send the synchronous request to the server. I am the source and I am the trusted client equals to T. So like the way he can able to convey the message to the server. Similarly, he can able to provide acknowledgement to the server also. So similarly, after receiving any acknowledgement from the system, the attacker can able to predict that numbers what I am going to generate in the next minute or next way. So now I am going to send the different malicious commands to the server to which has to respond. So to respond of the server to the client, the attacker can able to send some bad data or malicious commands because he can already send the request and the acknowledgement to the server. So now server is listening. What server is listening? The client is able to send some request or send some data. So now I am going to ready with the help of the request. So at that moment, the attacker can able to predict that next minute and he can able to send some bad data or malicious commands. So now after sending this bad data or malicious command to the server can able to give the response, give the application to the attacker. So which is not able to access by the client. So here the attacker can able to act as a trusted client, but he is not a trusted client. He can act as a trusted client. He send some requests, he send some acknowledgement. Along with that request and acknowledgement, the attacker sends some bad data or malicious command to the server to interacting with the server. So here the attacker able to predict that all the requests as well as acknowledgement to communicating with the server. He can directly able to send the commands, different malicious commands or bad data to the server. So here the next number, the next digit or the next step what will happen to the server is going to be predicted by the attacker. So like the way the TCP sequence and number prediction problems will occur in the TCP protocol. So to define against sequence number prediction, what we have to do? So what we have to do? We have to increase the rate of change of ISN. ISN, that is nothing but internet sequence numbers we are going to change. We are going to increase the rate of change of internet sequence numbers and increase the granularity of the increase. That means you have to increase the levels of increasing change of ISNs. So however we are doing here increasing the rate of changes. Now what we are doing here, increase the rate of change of ISN, again granularity wise. We have to improve. We have to increase. And a cryptographic algorithm for ISN generation. So internet sequence generation purpose, we are going to use some different types of algorithms. So they are going to asking for to maintain some cryptographic algorithms for generation of these ISN numbers, and good logging and alert mechanism. So every time you have to check each and every record that is inserted or that is deleted from the network. So we have to focus on the logging and alerting mechanisms. We have to focus on logging and alerting mechanism. So these are the defense techniques we are going to use against the sequence number predictions. And second one is what? Source routing vulnerabilities. Source routing vulnerabilities. So to transfer the data, we are going to use source as well as destination. Source as well as destination. So now what we are going to do here, so client is able to contacting with the server. Client is able to contacting with the server. In the middle, the attacker is going to take the control over client. So the attacker is going to hack the client system, as well as the attacker is able to acting like a client. So, but server does not able to identify that attacker is client or not. So whoever the attacker is client or normal client, the server is thinking like only the client sends some request. But real time what it is happening here, the attacker taking the system control over him, and he is passing messages as a client. He is going to pass some messages as a client. But server cannot identify that attacker is client or not. So at this moment, the attacker is going to find some different methods to injecting some different poisoning techniques and use that route to transfer the data. So attacker is going to identify that route, whoever the client and the server is interacting. So finding that route, and attacker going to injecting some mechanisms or injecting some inputs so that the route will be destroyed. And the attacker takes all the control over this route. So at that moment, he is going to destroy all the source routing vulnerabilities. He is going to destroying all the source routings. So that means the vulnerabilities, the giving chances to attack on the middle of the route. So there is this is a chance to giving the giving the chances to the attacker to interfere in the middle of the route. So here you can say that like only. So client can able to send the messages to the server with the help of attacker. So that means attacker is acting like a client. And the attacker takes control over the route, and he can able to hand over all the route, and he can able to send the data to the destination, send the data to the server. So to avoid these source routing vulnerabilities, or to defend against these source routing vulnerabilities, what we have to do? So we have to take some defensive techniques like reject external packets. That means the external packets are nothing but coming from outside connections. So better to prevent outside connections without any access control mechanism. And reject pre-authorized connections via source routing. So reject pre-authorized connections as well as. So those two we have to reject in the middle of source routing vulnerabilities. And next one, third one, routing information protocol vulnerabilities. So generally the packets are going to be transmitted from source to destination. But in the middle of the road, the attacker is going to stand there, and the attacker is going to convey the message in the bogus way. That is nothing but he can advertise the bogus routing information. Suppose this is the route actual. So the data is going to be transferred from A to Z. So but here A is acting like an attacker, and he is going to tell the information, he is going to convey the information to all the different spots, all the different spots or different packets. I am the one hope from G, I am the one hope from G, so please use me to find out the route, please use me to find out the route. So like the way he can convey the message in the middle of the route. So routing information, they can able to divert all the routes, by providing information about him, providing information about him. So that is nothing but advertise bogus routing information. So non-directional routing information is going to tell non-directional or miscommunication information, miscommunication routing. So that is the first thing in the middle of routing information protocol will happen. And here climb a route to particular unused host. So you can able to use the next E route or next C route or next D route or next F route or next G route. So you can able to access all the routes. You can able to access all the routes. So climbing a route to particular unused host. That is nothing but impersonation. That is nothing but impersonation. That is nothing but intentionally he wanted to use that route. Intentionally he wanted to use that route to provide a miscommunication, and climb a route to an active host to draw traffic to itself for inspection or alteration. So he can able to climb that route, so providing as an active host to draw a traffic or to itself for inspection or alteration. So wherever the hopes are there, so all the hopes are going to be acting like a active host with the help of attacker for the inspection or alteration. And a compromise address based authentication protocol. So address based authentication protocol is one protocol which provide address for each and every hop. So that protocol also compromised with this help of attacker. So now attacker wants to take all the each and every hop information, and he can spread all the bogus information to all the hops, as well as he can climb a route to particular unused host, and he can able to participate actively for all the hops to spread the bogus information, and he can compromise address based authentication protocol also. So like the way routing information protocol vulnerabilities, that means there is a chance, there is a loopholes to give chances to occur an attacks. So to avoid that attacks, to defensive that attacks, what we are going to do, some defensive techniques. So defense against routing information protocol attacks. So the paranoid gateway to filter packets based on source or destination address. So paranoid gateway is nothing but trusted gateway or authorized gateway we have to use. To filter packets. That means the each and every packets are going to be transmitted. So all the packets are coming from trusted source or not. We have to identify. We have to filter them. So based on source or destination address. So if the packet is coming from the authorized address, then no need to worry about that one. If it is coming from not authorized address, then we have to filter the packets and delete the packets. So that is one technique. And check the routes before accepting them. That means when we are before going to accepting the packets, automatically we have to check the route for each and every packet. So how it is going to be transferred. So you need to check the routes. And authenticate routing information protocol packet. So we need to authenticate. That means we have to provide some credentials or provide some authorized proceedings. So that is nothing but using public key is expensive when broadcasting. So using public key is expensive when broadcasting. And next one, good log generation and notice anomalies. So every time we have to focus on the generation of the packets, so focus on the logging of the packets. Focus on the generation of the packets as well as the logging of the packets. So by doing this, all the defensive techniques, we can able to avoid these routing information protocol vulnerabilities. And Icmp vulnerabilities. So Icmp vulnerabilities are nothing but So these are the ping statistics vulnerabilities. We can say that ping statistics vulnerabilities. So those are having direct messages or redirect messages, indirect messages or redirect messages. So here the ICMP stands for Internet Control Message Protocol. It redirects message from gateways to advise better routes may be spoofed. So if it provides a better gateways and if it provides better routes, that may be spoofed with the help of DNS spoofings or IP spoofings. DNS spoofings or IP spoofing. So here there is a chance to spoofing of that domain name address as well as internet protocol address. So here that's why the better routes may be spoofed with the help of these spoofing techniques. And among these, denial of service attack from spoofed destination, unreachable, time to leave exceeded, subnet mask, reply message. So these are all some different types of denial of service attacks from spoofed destination, unreachable, time to leave exceeded, subnet mask, reply message. Some of the messages will get after ICMP vulnerabilities happen in the real time. ICMP vulnerabilities happen in the real time. So for that, what are the defensive techniques we are using? So for the defensive techniques, so check to ensure that the message belongs to the particular connection or not. So first of all, we have to check. So in the previous, we are checking that each and every packet and each and every packet source and address, whether it is coming from source trusted address or not. But here we are going to check that message belongs to the particular connection or not. Particular connection or not. And to verify whether the reply message contains a reasonable sequence number or not. So that the reply message contains reasonable sequence number or not. That means whenever the requests are made, automatically there is a chance to generate response numbers. There is a chance to generate responsive numbers. So for each and every reply messages, there is a chance to reasonable sequence number. So we need to provide that sequence number has to be reasonable. We need to provide that sequence numbers has to be reasonable. So restrict route changes to particular connections. Restrict route changes to particular connections. So we have to restrict some route changes to the particular connection. So some of the connections we are going to divert the routes. So at that moment we are going to restrict the route changes to the particular connections or limited connections. And honor reply packets only at the appropriate time. So honor reply packets only at the appropriate. That means whenever you send a request, at that time only the reply packets can be done. Unwantedly, the reply packets may be leads to the destroying honor of the packets. So appropriate time, whenever the need of the packets reply, at that moment only the reply packets will be honored. So that is one defensive techniques. So these are all the different types of ICMP vulnerabilities and routing information protocols vulnerabilities, sourcing routing vulnerabilities, and TCP sequence number protection. So once again we'll revise these all the topics. So what we understand from this session, so security problems in the TCP/IP protocol suite. So first of all, what is meant by TCP/IP protocol suite is nothing but the TCP/IP protocol contains all the different types of protocols which were existed in each and every layer, so that we can say that all these protocols are accumulated as a TCP/IP protocol suite. So here the application layer contains some protocols, transport layer contains some protocols, internet protocol contains some protocols, network access layer contains some protocols. So each and every protocols having a certain regulations or certain principles to transfer the data. But at that moment, some of the problems will be occurred in the TCP security. So what are the problems actually? The first problem is what the TCP cannot give the guarantee on message modification attack. TCP cannot give the guarantee on segment against message modifications attack. And second one, TCP cannot keep segment data to be secure against the message eavesdropping attacks. And third one, TCP cannot protect connections against unauthorized access attacks. So because of these several security problems we may facing with the help of some different problems, like first one is sequence number prediction, and the second one is source routing vulnerabilities, and third one is routing information protocol vulnerabilities, and fourth one is ICMP vulnerabilities. So these are all the different security problems. These are all the different security problems in TCP. We are providing security in the network oriented, in the data oriented, but in the protocol oriented there is a chance to occur different security problems in the TCP IP. So that moment the packets are going to be attacked by attackers, and the packets are going to be predicted by attackers, and they can use the network to attack the entire network to transfer the different data, to transfer the different data. So these are all the source routing vulnerabilities, the routing information protocol vulnerabilities, and ICMP vulnerabilities, and all the defensive techniques against these all the security problems. These are all the security problems. So that is about security problems and defensive techniques in TCP IP protocol suite. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.